This conference will now be recorded.
Hi guys, I hope you can see my screen. So just a quick recap of what we learned in the previous session before moving on. So in the previous session, we have started learning about Sqoop. So Sqoop is a simple data transfer tool which is used to transfer your data from RDBMSs such as MySQL or Oracle to HDFS or Hive and then vice versa, right? So we have seen this architecture of Sqoop, right? It can do only two things: import and export operation. So then we spoke about the Sqoop version, how the importance of JDBC jar file, right? Then we have used Sqoop help to see the list of all the commands, and you can even get the help on a specific command as well. And more importantly, it's very important to understand whether you have your database up and running or not before you try to transfer the data from it. So that's how we can actually confirm it by running these commands. And we have spoken about this checklist that is required for Sqoop. And then we have seen Sqoop list databases to see the list of all the databases. We have seen Sqoop list tables as well. And we have seen the different ways of giving the passwords, right? There are three different ways of giving the password. Then we have seen how to use options file to keep all the parameters in a file and then use it. Then we have seen about Sqoop eval as well. So now let's talk about Sqoop import. What is Sqoop import and how to do it? So let's actually go to the Cloudera Quick Start VM. So this is my Cloudera Quick Start VM. I'm going to log into the MySQL database for now. So let's go ahead and log into the MySQL database. So right click anywhere on the desktop, say open in terminal, maximize. Then here um, I'm going to basically connect to my database such as MySQL database. So first increase the font, click on view and zoom in twice. So I'm going to connect MySQL space hyphen u root hyphen p Cloudera. So set the terminal title, terminal set title, give it as MySQL, and then I'm going to open another terminal, and then I'm going to use this for Sqoop. So terminal set title, give it as Sqoop. Click on view and zoom in twice. So go to the MySQL tab here. You can say show databases to see the list of all the databases. So out of this, I would like to switch to this database called as retail DB. So I can say use space retail DB. Then you can see the list of all the tables by saying show tables. So now I would like to import this table called as orders table, which is in retail DB by using Sqoop into HDFS. So first step is I'm going to check the contents in my HDFS location. Let me check the contents in my HDFS location by running this ls command. I have some contents, but I wanted to clear out everything. Hence, I'm going to run this command rm with hyphen r option. So I wanted to clean up everything in user Cloudera path to start before starting the import operation. Then I can confirm it by running ls command just to be sure that I don't have any contents. I don't have any contents right now. Now I would like to perform the import operation. I would like to perform the import of orders table into this HDFS location. Let me do that. So let us go ahead and build the query, and then we will try to use that query to start the import operation. So right click anywhere on the desktop, say create document, empty file. Let's say Sqoop import, you can give any name. Open that document and then start building your queries. So Sqoop import, then give your connect string hyphen connect jdbc colon mysql colon // localhost colon 3306, and then mention the database name. Database name is retaildb hyphen username. Username is root hyphen password is Cloudera, and then mention the table name. So the table that we would like to import is nothing but orders table, and you can get that here, right? So orders table from retail database is something that we would like to import. So you have to mention the table name here. Table name is orders, and then you have to mention the target directory. So hyphen target directory, and you have to mention the location such as user, Cloudera, and then orders. So right now, if you go and check in your user Cloudera path, there is nothing. Now, once the import operation is done, it will automatically create a folder for you with the name called as orders, and within that directory or folder, you will find all the contents. So let's copy this command. Go to the Sqoop terminal, right click and paste it. Enter. So it will take a couple of minutes. So let's wait for 2 minutes. So the import operation is done, and very important processes you have to understand about the internal details. So that is really important. So let me scroll up. So this is the place where we ran the query, right? And as I told, you can ignore these first two lines. And then you can see the Sqoop version that it is trying to use is 1.4.6. And then you can see it showing as beginning code generation. So this is an interesting one. So what have we learned? We have learned that it will actually use MapReduce jobs in the background to actually basically perform the import operation, right? So MapReduce job is actually nothing but the Java code, and that Java code has been generated for us, and then that Java code is actually used to perform the import operation. But now the question is, where can I find this Java code? You can see code gen tool, beginning code generation. So if you just say lsfn in the same directory wherever you are, you can see orders.java file. Just open this file. It's a Java file, va space orders.java. So this is a Java code again. You don't need to worry about understanding any of this Java code. You can just have a glance at it. Then you can just come out of this. So the point is clear. So automatically the Java code is generated by code gen tool. You can see that here clearly. Code gen tool beginning code generation. Now based on what this Java code has been generated. So that's where you can see this SQL statement or SQL query. Just copy the SQL query, select it, right click copy, go to the MySQL terminal, right click and paste it. So you can see that it is trying to get us the sample record. Based on this sample record, it is basically trying to generate the Java code for you, right? It's going to get this sample record. Now based on this sample record, it's actually going to generate the Java code for you by using CodeGen tool. And then this Java code has been compiled. So compiled is nothing but So you can see compilation manager. So the compilation manager is something that is actually used to compile this Java code. Compilation is nothing but just checking for any syntax errors or not. So let's do one thing. Let's copy this path. You can see there is this path here. Let's copy this path. Right click, copy it. Say LSF and LRT. Then right click and paste that path. So now have a look here. We have only the dot class files. So whenever the compilation manager compiles your Java code, .java code, it will compile your code and it will create dot class files. It is actually called as bytecode or machine code. And all these dot class files are zipped together or packaged as a single file called as orders.jar. So jar basically stands for Java archive, right? So and then this jar file could be used to perform the import operation. So now I'll scroll up. So now you can see that here you have the orders.java file, and then compilation manager is going to compile your .java code. It's going to create a .jar file, and then if you can scroll down, you can see it showing us beginning import of the orders, and the very important concept is nothing but this bounding wells query. So before talking about bounding wells query, let me ask you a question. So suppose let's say that you're working in a team of 10 members, and generally you will get a work as a whole, right? So the work should be divided among the existing team members. So what if some team member is working more, some team members are working less, right? That should not be the case. Every team member in the team should do equal amount of work, right? Nobody should be underloaded, nobody should be overloaded. The same concept is applicable here. So here we are trying to connect to a database and try to pull all the records from it. So then we have the concept called as mappers, and each mapper will make a separate database connection to pull the records. But now the question is, but now the question is, based on what we will decide the number of records to be imported by each mapper or each thread. That is based on this bounding wells query. Let's do one thing. Let's try this query. Let's select this query completely. Select it, right click, copy. Go to the MySQL terminal, right click and paste it. So have a look here. It is trying to get the minimum value and maximum value based on the order ID column, right? So let me make a note of it. I'll make a note of min value and max value. So min value is 1 and max value is 68,883. Right? So min value is 1, max value is 68,883. Now here we have to figure out the number of records to be imported by each mapper or each thread, right? So that's what we call it as split size. So the formula for split size is nothing but max minus min divided by number of mappers. So the default number of mappers is actually nothing but 4. So now if you substitute all these values in this, so max value is 68,883 minus min value is 1 divided by default number of mappers is 4. So 68,882 divided by 4. So let's do this calculation. So 68,882 divided by 4. So this is like 17,220. So this should be the number of records to be imported by each mapper or each thread. So the first mapper We'll start importing from the first record till 17,220th record. First record till 17,220th record. How about the second mapper? The second mapper will start from the next record, 17,221st record till again the split size, because every mapper should do equal amount of work. So the starting record is 17,221 plus the split size 17,000. 1 minute. I'll type it again. So 17,221 is the starting point plus the split size is 17,220. So the second mapper will import till 34,441. So that is the end record. So how about the third mapper? So the third mapper will start from the next record again. 34,440 second record till again the split size. So let's do this calculation. So 34,442 is the starting point plus the split size 17,220. So this is equal to 51,662. Then how about the next one, fourth mapper? So this will start from the next record, 51,663rd record till again the split size. So let's do this calculation again. 51,663 plus the split size 17,220. So this will be 60,883. Yes, I hope it's clear for you. So the point is very clear. There are totally four mappers. Every mapper should do equal amount of work. When I say equal amount of work, every mapper should try to download, or every mapper should try to get equal amount of records. So that's where we have this concept called as bounding whiles query and then split size. Right. So this is very important concept. So now, so be very clear with bounding whiles query and then split size. Also, you can see the split size is showing us 17,220 here. Number of splits is showing us 4, which is nothing but number of maps as 4. Number of mappers as 4. And you can also see the min value, max value. Min value is 1, maximum value is 60,883. Now based on this, you can see that it's trying to submit the mapper to job, and then you can also see the number of records it imported. 60,883 records. So now let's go ahead and check the HDFS location. We didn't have any contents in HDFS location. Now, if you go and check in user cloud era path, you should have a directory. You can see that we have orders directory created automatically because we have mentioned it as a part of the target directory. Let's go inside orders. So just to see the output clearly, I want to zoom out a little bit. Click on view and zoom out. Let me run it again. So now have a look. We have exactly 4 files. Right, you can see exactly there are total 5 files, but the first one is an empty file. Underscore success is an empty file. You can see the size is showing us 0 bytes. So the first one is an empty file. That is just an indication that the import operation is successful. And apart from that, there are totally 4 more files. Also, if you run ls with -h option, you will see one more interesting thing. You can see the sizes of these files are almost same, right? The sizes of these files are almost same. You can also figure out the number of records imported by each mapper. So you can say HDFS plus DFS hyphen cat and then try to pick up one of the file and then paste it. So what will this do? This will try to show the entire contents of the file, right? But that's not what we are looking for. We wanted to get the number of records. Hence I can say WC hyphen L. So WC is nothing but word count, L is nothing but number of lines. So the first mapper imported 17,221 records. How about the next mapper? So the next mapper also imported almost the same number of records. How about the next one? You can see it imported 70,220 records. How about the next mapper? 70,221. So you can see that every mapper or every thread is trying to do almost equal amount of work, right? Now you can also say star. So this will get you the total count of the records. So totally all the four mappers together imported 68,083 records. You can also double check whether this count is matching with the count of the records or not. You can go to MySQL tab, select count of star from orders. You can see the counts are matching, right? You can see that the counts are matching. So now let's do one thing. Let's try to see the sample content from one of the file just to confirm the things are fine or not. So to check the contents, I can use tail command, hdfs plus dfs hyphen tail, and then pick up one of the file, select it, right click copy, right click and paste it. So now you can see the content is looking good, right? Also you can confirm the same by running this query here, select star from orders limit 10, right? You can see the top 10 records. So this is very important, guys. So in the interviews, you'll get this question as in two different ways. So the entire question could be they'll directly ask you to explain Sqoop import internals, or they may ask you Sqoop execution lifecycle, or they may ask you what happens internally when you do Sqoop import. So these are the three different ways of asking the same question. So just be prepared for the same. So now I have noted on all the points here. Let me go back there. You can see that here, right? So so look at the first point. So the first, with respect to the Sqoop execution lifecycle, the first point is it will try to connect to the source database and then it will try to get the metadata information. So basically, trying to get one of the sample record. Based on that sample record, it's going to generate the Java file, and then that Java file has been compiled to generate a jar file. Then we have seen that it will run a bounding wells query to get the split size basically, and the default number of mappers is 4. Then it uses the split boundaries to issue the queries against the source database. So what is the meaning of split boundaries? So the split boundaries is nothing but this, right? So split boundaries is nothing but this. So they have a clear idea about which mapper have to import from which record to which record. That is nothing but the split boundaries. And then each thread or each mapper will make a different JDBC connection, database connection, to issue the query or to run the query. Then each thread or each mapper will get mutually exclusive subset of the data. So what is the meaning of mutually exclusive subset? So when I say mutually exclusive subset, so as the first record is trying to import from first record till 17,000 to 23 record, none of the other mappers will try to interfere there, right? So that's the meaning of mutually exclusive subset. Subset is nothing but out of 60,883, each mapper is trying to import only a portion of the records. So that is why it is called as mutually exclusive subset of the data. And the last point is important. So data will be written to HDFS in a separate file per thread. So read it again. Data will be written to HDFS in a separate file per thread. That is, for every mapper, there will be dedicated file. So that's why, as I told, by default, the number of mappers is 4. So that's why you also have exactly 4 files in your output as well, right? So sometimes they may ask you an indirect question saying, okay, based on what these number of files are decided, right? So it is actually based on the number of mappers. As the default number of mappers is 4, you will see exactly 4 output files here. And you can see the naming convention. So part hyphen m is nothing but mapper files. So this is very, very important, guys. So anybody have any questions in this? Let me know. I'll wait for 2 minutes. Any questions so far in this? Because this is very, very important. Okay, I think there are no questions. We are good to move on. So we spoke about code gen, right? So code gen is nothing but it's a tool automatically used by Sqoop import. Whenever you perform import operation, so code gen tool is automatically used by Sqoop import. It will generate the corresponding Java code for you for the table in the source database. So whichever is the table that you are trying to import, the respective Java code could be generated and it's taken care automatically. You don't need to run this manually. Whenever you perform Sqoop import, automatically CodeGen is called, automatically it will generate the Java code for you. Okay guys, so now if there are no questions, then I'll talk about the differences between target directory and then warehouse directory. So if you can notice here, when we are trying to perform the import operation, I was mentioning target directory, right? You can also use something called as warehouse directory as well to perform the import operation. Let's do the import operation of other table. Show tables. Suppose let's say I would like to import order items table, right? But this time I'm going to use warehouse directory. Let's copy this completely and paste it. Here the table name changes. Table name is order items. And instead of target directory, I'll give it as warehouse directory. So the main difference between target directory and warehouse directory is, if I'm using target directory, then I have to dedicatedly give the directory name also here, such as orders. But if you're using warehouse directory, you don't need to do that. It will automatically take care about creating the directory for you. Have a look here. I'm just giving user Cloudera. But as I'm giving warehouse directory here, it will automatically create a folder for you or directory for you with the same name as that of your table name, which is nothing but order items. So let's run this import and then see. Copy this, go to the Sqoop terminal and try to run this import operation. So the import operation will take a couple of minutes. We'll wait for a couple of minutes. So the import operation is done. Now, with respect to the overall process, it remains same. Whether it is target directory or warehouse directory doesn't really matter. So just to confirm, I can scroll up. So this is where we are trying to perform the import operation, and you can see that beginning code generation. If you say LSF and LRT here, you can see the .java file here. You can open this file, order items.java. This is a plain Java code again. You don't need to worry much about this. This should be fine for now. Then scroll little up. So this is where we are trying to generate the Java code, and then based on what it generated the Java code based on this sample query. So let's copy this sample query here. Go to the MySQL tab, right click and paste it. So based on this sample record, automatically the Java code has been generated, and then that Java code has been compiled by the compilation manager to get the jar file. You can see writing jar file, right? Order items.jar. Then it's saying beginning import of order items. It follows the same process as I told earlier. You can see it's also running the bounding values query, right? So let's copy this. So this will run the bounding values query to get the min value and max values. So the min value is 1, max value is 170 to 198, right? And then based on this, it will try to calculate the split size. So how to calculate the split size? Max minus min. 170 to 198 minus 1 is 170 to 197. So let's do this calculation. So 170 to 197 divided by default number of mappers is 4. So you can see approximately the split size should be 43,049. 43049. Is it matching? Yes, it is matching. You can see split size is showing us 43,049, and number of splits is nothing but the number of mappers. By default it is 4, and you can see the min value is 1, max value is 170 to 198. So based on this, it will try to run the mapper job, and then you can see the total number of records imported. It is showing us 170 to 198 records. Is this matching with my original table? Let's figure it out. Select count of star from order items. So it is matching 170 to 198, right? Now the important point is we have mentioned it as warehouse directory, right? And I haven't given any directory name such as order items. Let's go and check the output in your HDFS location. So I'm checking the contents under user cloud era path. You should have an automatic folder created such as order items. So the point is very clear. If you use warehouse directory, you don't need to give that dedicated directory name here. It will be taken care automatically. But if you're using target directory, you have to give a dedicated directory. Right? I hope we are clear, right? Any questions so far? So that's the main difference between target directory and then warehouse directory. Now let's talk about managing the directories. We have already performed the import operation of orders directory, right? So orders table. What will happen if I try to perform the import operation again, once again? Let's see. So I'm going to take this, I'm going to copy this, I'll go to the Sqoop terminal and I'll try to run this again. Let's see the results. Now if you can scroll up, you can see it's failing, right? The reason is we already have the output directory. So we already have a dedicated output directory called as user Cloudera. Hence it is failing. Now to tackle that, what we can do is we can use something called as delete target directory. If you use delete target directory, it will overwrite your contents. So let's try delete target directory. I'll copy this, paste it. So then you can mention hyphen delete target directory. Let's copy this and go to the Sqoop terminal, right click and paste it. So let it run, it will take a couple of minutes. I will show one important line here. So the import operation is done. So one important line that I wanted to focus here is this line, destination directory deleted. So because we have mentioned it as delete target directory, before starting the import operation, it will go and check whether we already have the directory with the name called as orders available or not. As it is already available, it will go ahead and then delete it. And then it will perform the usual import operation, right? Now just to confirm that it has deleted it completely, I can actually go here and then try to look at the timestamp of the files created. So just type date command. What's the current time? November 1st, 2013. So look at the timestamp at which these files have been created just 1 minute ago, which means before starting the import operation, it deleted all the contents and then it performed the import operation once again. So that's where, if you want to overwrite the contents, then you can use -f delete target directory. Now, if you wanted to append the content, you can use -f append. So before talking about append, let's see the total count of the records. hdfs plus dfs -cat. Let's take one of the file, select it, copy, right click and paste it. So then try to get the count of the records. So totally we have 68,083 records, right? Now I'm going to perform the import operation by mentioning -f append. Let's copy this and paste it. So here I'm going to mention -f append. Let's copy this, go to the Sqoop terminal. So the import operation is done, and because we have mentioned hyphen f and append, you can see these two lines extra, right? Appending to the directory orders. So now let's go and check the contents. So initially we had 4 files. Now we'll have 4 more files created. Have a look here. We have 4 more files created. Because we are done the import with append operation, hence we are seeing 4 more files extra. So let's also get the count of the records. So I can just get the count of the records this way. So initially we had 60,083 records. Now we have same number of records added, so it should be doubled. So I can confirm that. So initially we had 68,883 records. So now the count of the records is doubled. So if you look at the count, so you can see the count of the records is matching 137766 because we have done the append operation. So then we can also change the number of mappers by using hyphen f num mappers or hyphen m option. I think let's stop it here. We'll continue tomorrow, right? So if you have anything pending from previous sessions, please wrap it up, um, because from tomorrow onwards it will be 1 hour sessions. Okay, just be prepared for the same. Any questions anybody have before closing the session? Okay, I think we're good for today. Let's meet tomorrow. Yeah, see you guys. If you have anything pending, please try to wrap it up by tomorrow with respect to practice, because from tomorrow it will be 1 hour sessions. Just be prepared for the same. Okay, see you then. Bye.
Thank you.
Okay, guys, I'll give you the access. See you tomorrow then. Bye.